Hi friends, welcome. In this session, we look at what the machine learning is and see what impact it makes on software development in today's data era, what exactly it means and all that. So that's agenda of this session. We look at the drawbacks of traditional software design, then try to understand how this can be solved through the machine learning. So to begin, we see what the machine learning is all about, and then we see why machine learning is required, and then it is time to see how machine learning can solve our complex problems. Then look at the various types of machine learning models available, and then look at how they are implemented, and finally understand what the concept of transfer learning is all about and how it makes the whole world different, and finally conclusions. So let's try to understand what the traditional way of software development was. It's something to do with SDLC, software development life cycle. The first step is to get the requirements, second step is to understand the requirements, then understand the domain. So always the problem with the software engineers is the domain is always unknown, because what we study in our curriculum is about the software development, designing, that's everything to do with the software. I mean, languages, data structures, database, object-oriented, networking. These are the various things we study, but nowhere we study about the domain to which the client belongs to. A client belongs to any domain except software. If the client was well versed with the software, then definitely he or she would not be our client. He or she would have solved the problem themselves. They don't have to come to us to get their problem solved. So they belong to any domain except the software. And these domain information, none of them is taught in our course, in our curriculum. So for example, if you want to work on the share market and try to give expert advice regarding what to do with the shares, should we purchase the share, should we sell the share or something, then it requires a lot of intelligence, lot of domain knowledge which an expert has. The expert has studied something related with the finance, studied about the stock market, and he's been working with the stock market, has an experience of the stock market, and he has seen the stocks going up and down, and he has tried to analyze why they go up, why they go down, and all that. But none of them are known to any software engineer. None of these the software engineer does, never studied any of them in their curriculum, and that makes a big problem. So always we work with the unknown domain, and we have to understand this domain before we continue to solve the problem. So while solving the problem, after understanding this domain, we have to design. So to design, the primary requirement is to understand the domain thoroughly. Unless until we understand the domain of the client, we cannot solve the problem of the problem's domain. Till we understand it thoroughly, we cannot solve it, we cannot design the solution. Once we design the solution, then the technical part, that is the software engineer part, comes in picture. So how to implement that, what language to use and all that, yes, that's what we have studied in our curriculum. So here, whatever we have studied in our curriculum may come to our aid, but till now none of them was taught in our curriculum. That's a major challenge any software engineer is going to face. Once the ideas are implemented, and then it is time to test whether the implementation is working according to the requirements or not. If it is not working according to requirements, then we need to have a feedback and go back and see did we implement it correctly or not. If no, modify the implementation. But if we feel that implementation was done exactly as per it was said, then definitely there may be problem with the design part. So go back one step and see whether design is done correctly or not. If design is not done correctly, then make corrections in the design and then again implement and then test it. So this process continues. If you find that design was also right, then definitely there may be problem in understanding the domain, problem in understanding the requirements. So go one step back and then redo this work and again continue. So this whole thing keeps doing again and again and again, so that goes into the loops, and then at the end we come out with a working model, and that model we deploy and the client starts using it. So that's the traditional way of developing any software. So what are the drawbacks of this traditional software design process? Yeah, this first thing is it is rule based, and these rules are going to explode if the complexity of the problem increases. So for complex problems, the number of rules grows almost exponentially, and the size of the rules grows so large that it won't be practical to implement it. So for example, for writing rules for face recognition is almost impossible because of variation in lighting, variation in angles of the person's face and expressions and all that. So you just can't say that at this point the intensity should be this much, at this point intensity should be this much and all that in the whole frame, and say that if this is this, this is this, this is this, this is this, then the person is so and so. So it is not that simple, because we don't have any standards of taking a photograph and all that. So whether it is followed some standard or not, our aim is to identify the person in the photograph. Then there are many variations possible in getting a photograph, and all these variations should be understood, and for that we do require some intelligence. As we have never seen a person in a particular pose, but still we are able to convince ourselves that this person should be so and so, because in other positions, other orientations, we might have seen that person, and our brain intelligence tries to correlate them and somehow connects all the previous information about that person and says that yes, this person is so and so. But for creating the rules like that is almost impossible. The next drawback is inability to handle the uncertainty. So we do comfortably work with unsettable situation, and somehow we manage it even if we exactly don't know the answer, but somehow we try to answer it. So the example for this I can give is we have studied some question answers regarding to one particular chapter or particular topic. Some questions and answers we have gone through, and when we enter into the exam hall, we get a question, and definitely that question doesn't fit with any of the questions we had studied earlier. But yes, we can somehow connect the questions what we have seen earlier to the question what we are seeing now in the question paper, and connect those answers, and somehow we create a new answer for that which almost matches with the question being asked, and that requires intelligence, and we lack intelligence in our system, and hence it becomes too difficult to handle uncertainty as a human naturally works on. So the traditional software expects clear deterministic inputs and deterministic input output relationship and all that, which all the time is impossible to have, and hence difficult to create a traditional software when we have uncertainty in the inputs. Then we have a limited predictive power. That means traditional design can only follow predefined rules. It cannot predict future outcomes based on the trends and all that. It can only say that compare the past and talks about the past, but cannot talk about future. So cannot predict the future. The traditional softwares cannot predict the future and all that. So that makes our problem more difficult, and hope this problem we think our machine learning can solve us. And to know what machine learning is and all, we look in the next session. Thank you. We have seen in our previous session how difficult it is to solve any bigger problem using the traditional software design approach. That's where the machine learning comes to our aid. And to know what machine learning is, let's get into it. Machine learning is a subset of artificial intelligence that enables computers to learn from the data. Yeah, here the computer is given with the data and said that, look, this is data, understand the data, understand the features hidden inside the data, and get ready to answer my questions. So that is how we create some sort of intelligence to the machine, and that is through what we call making machine learn from the data, that is machine learning. So the machine learning will improve the performance without being explicitly programmed. So we don't have to understand the complete domain, we don't have to understand how to solve the problem, and then we don't have to explicitly write a program to solve that problem. So what we require is the data. So when we were talking in the last session, the major problem with any computer engineer is that he or she will be working in some unknown domain, having no expertise about that domain. Then what are we actually trying to do was trying to imitate the domain expertise through our software. So we meet a expert who is the domain expert, and then interrogate with the domain expert and try to understand how the expert solves a problem, and we try to simulate that through our code. Today that seems impossible because the expert is far beyond the understanding of any software engineer. So what we can do is try to understand what the expert is doing instead of understanding how expert solves the problem. So today the advantage we have is, one, lot of data is available. Two, the processing capacity has increased. So taking these two into considerations, so what we can do, instead of interacting with an expert about how the expert solves the problem, just look at the past history of the expert and fetch the data available with the expert, the previous problems expert has already solved. Collect all those data and then ask our machine to see that these were the problems given to the expert, and that was the solution given by the expert. So can you connect the two ends, the problem given to the expert and the solution given by the expert? Can we connect any link between these two? Not as a human me, but I want my machine to connect the links. So while connecting the links, it will learn how the things are interrelated and all that, and that is what we call machine learning. So we don't have to understand how the problem was actually solved by the domain expert, but instead we can collect the past solutions of the expert, whatever problems the expert has already solved, collect all those data and then dump onto our machine and ask machine to learn the connection between the question and answer. And once we make our machine understand the relation between question and answer, then our machine will be ready to answer any new questions related to that particular domain. That is the basic concept of machine learning. And through this we can create machine more intelligent. So here the machine learning will be provided with data and algorithms that allow the system to recognize the patterns, and once the patterns are understood from the data, then this pattern can be used to make future decisions or predictions. So that is the main concept behind the machine learning. Question comes is, why do we require that? The first thing is the traditional programming works well for simple rule-based problems only, but the real-time problems any domain faces cannot be put in simple set of rules, and hence the traditional way of solving cannot be used for it. So whether it's speech recognition or medical diagnosis or fraud detection, so it is almost impossible to create the rules manually, and since we cannot create rules manually, then the traditional programming cannot be used for that. So for example, if I ask you how to write A, yeah, so it is almost everybody knows how to write A, but what we can do, we can write A, we can recognize A if it is written, but the problem is I cannot explain someone else verbally how to write A. I can show how to write A by writing A, but I cannot verbally say how to write A. And believe me, A is the simplest thing anyone learns in the life, and A itself, that's the simplest thing we are unable to express in words. Then imagine explaining the domain expertise in words. It's almost not totally impossible. So that's a major problem we do have, is we can't just make rules for any expertise. For that expertise, what is expert means? So first thing is that expert has got a studied something and developed some knowledge, and using that knowledge has done some activities, and through the activities he has gained the knowledge, the expertise, and that expertise will simply make the expert to solve a problem. But when it comes to explaining how it is solved, not possible to explain, because solving a problem by an expert involves many things. One, the past studies, then the knowledge gathered in all the past years, and the problem solving skills acquired during the current working duration. So this experience and all that, everything collectively, something happens inside our brain which we call knowledge, and that's what we call an intelligence. And that intelligence is one that helps us immediately come out with the answer without explicitly working on it like a program does it. No, we don't work like a computer working on a program. we are wired in a different way, our brains are wired in a different way. So if you are talking about understanding A, B, C, D and all that, what is actually happening is the A written by our teacher on the board is seen by our eyes, and she keeps telling that this is A, this is A, this is A, and whatever she is saying that this is A, this is A, it goes into our ears. So what goes into our eyes ring a bell in some part of the brain, and what goes into our ears ring another bell in another location in our brain, and these two firing occur every time A is being taught to us. We see A, we hear A, we see A, we hear A. These two things are happening all the time simultaneously. So two parts of the brain are getting fired simultaneously when we are trying to learn A, and because of this, a connection between these 2 points is created, and this connection creation is what we call learning. How it actually happens, no one can answer it. It's only an approximation that some neurons get excited when you see A, and some neurons get excited when you hear A, and these two neurons, a connection is created between them, and that is what we call learning. Same thing happens whenever we are experiencing any new thing, whenever we are learning. So when we talk about a domain expert, then so many such things have happened with that person. So many places neurons are getting fired, and so many new connections are being done, and through all this, and intelligence is created, and through that intelligence he is able to solve the problem, and that is not possible for that expert to tell verbally how the problem is solved and all that. But yes, of course, in the back end we have the various cases that expert has already solved. So take those cases as a reference and try to find a pattern in that, and that is what we call machine learning, and that's why we want to work with machine learning. So machine learning is one which allows systems to adapt and improve automatically by learning from experience. Yes. So imagine that you are working with some 10 questions from a particular topic. So you have studied some topic, and now you are familiar with 10 questions and their answers. Now what happens when you get into an examination hall? You get a question, you know that it belongs to that particular topic, but the question in the question paper doesn't exactly match with all these 10 questions. Yes, but still we try to correlate this question with the 10 questions we have, and then on the same way we try to correlate those answers and somehow extract the required answers from those 10 answers and put it on one answer. This is what we call intelligence. So we do use our intelligence, deeply go into our knowledge bank and look for what we are interested in, and if it is directly available, just dump it out. But if it is not available, then look all around and try to find anything nearby is available. If so, then try to extract what you want from that and put it out. So that is intelligence. So we are trying to make a machine intelligent. That is what we call artificial intelligence, and here it is going to allow the systems to adapt to new situations, improve automatically by learning from experience. They do some, when you ask a question, it gives some answer, and from the feedback it understands how good the answer was, and depending on that feedback, the same answer to be repeated again for similar question or not to be repeated again is decided, and then the next time a similar question is asked, this answer to be used for creating new answer or not is to be decided, and this whole process is what we call learning. So that's a difference between the traditional and machine learning if you look at it. So if you look at our approach than the traditional development. Here programmer explicitly defines the rules and logic. Here we have to understand everything in detail and put everything on paper and then decide it. But whereas here we don't do anything, we just dump the data and we ask system to learn the rules or patterns from the data. We just give the data and we ask you find the rules and the patterns from that. The input to the traditional software system is rules plus data we give and we get an output. So we have rules, so with that rules we write a program and to that program we feed the data and we get the output. Whereas in the machine learning case, we have collected the data from the expert and we know what for that data or what that data means. So we have data as well as the output, both of them we feed to the machine and let machine create the rules. So it will give us the learned rules. So about handling capacity, so this traditional one works well for simple problems like creating payroll, billing, etc. But cannot handle complex tasks, uncertain tasks and all that. So but machine learning can comfortably handle any complex situation, uncertain situation, unstructured problems like image processing, language processing and all can be comfortably handled by machine learning. Adaptability, so a lot of manual updates are required if something changes, but here automatically it gets adopted. The moment you change the data, the whole system, the whatever system you are talking about will now start working for new set of data. So if it was working for identifying animals and now you start giving input to the machine to identify the birds, then the same process it will start identifying the birds and all that. So adaptivity is very simple because the basic rules are fixed, that is take the input, take the output, take the data, take the output, create a model. So whatever is input output, the logic is the same. And scalability, when the problem becomes more complex, then scalability is a very big problem, whereas it's going to improve with more data and more computational power. So you have more data, you are more happy because more the data we have, more better our machine can learn it. So it is like writing A 10 times. Instead of writing A 10 times, you write A 100 times, then you will be more perfect in that. So the more exercise you do, the better learned you will be. The same way, the more data we have, definitely our performance is going to improve. So it's scalable, easily scalable. So the size of the data and all that will not matter much when it comes to machine learning. So that's the difference between the traditional and machine learning. So as of now, that's it for now. Thank you. Hi friends, now it is time to see the various types of machine learning algorithms available. So mainly there are three types of algorithms we have for machine learning or making our machine learn. The first one is called the supervised learning, where our data contains both input as well as the output. So we have a data set where we have input and its corresponding output, and these two together are given to the machine, and the machine somehow should find the correlation between input and output and create a model. And this model, when given with a new input, should provide us an appropriate output. So this type of learning, where the data contains both input as well as output, is called the supervised learning. So there's another one where only inputs are available, no output is available, and these inputs are used, and from the input the features are extracted, and the inputs having common features are clustered together. So there is something like clustering we can do, or when we try to find the features, then usually the size of the features or the number of features is quite less than the data itself. So we can also claim that the size of the data can be reduced if we use the features instead of the data itself. So that's what we call the dimensionality reduction. So we have two types of unsupervised learning. One is the clustering technique, other one is the dimensionality reduction. Yes, we have one more type of learning, which is the reinforcement learning, where we don't have any inputs available, outputs available, but yes, we have rules to play the game, or rules of the system we have, and using these rules of the system, the inputs are generated and outputs are generated, and then the generated output for any given input, is it useful or not useful, that's tried to identify, and through that we have a reward or punishment system. So here what happens is we have something like an environment upon which agent acts, and the action of the agent will affect the environment, and this effect of the environment creates either positive effect or negative effect. If it is positive effect, then the agent gets a reward. If it is a negative effect, then the agent gets a punishment, and the agent keeps this information, and in future tries to repeat all the actions that fetch positive response or that fetch the rewards, and tries to avoid the actions that gives negative rewards or the punishments. So this is what we call reinforcement learning. So just look these one by one. So coming with the supervised learning, so here the model learns from the labeled data. That means we have the data in the form of input output pairs, and these input output pairs are used together and used for learning. So this input output pairs of data are given to the machine, and machine is asked to create a link between input and output, try to understand the correlation between input and output, and once the correlation is identified, a model is ready, and this model can be used to predict what output we can get for any given input. So the best example is the one we had used in our school days while we were learning. So here our supervisor was our teacher, who was trying to teach us what ABCD is and all that. And there, if you remember, that we were shown the image of A, or A written on the board, and she used to show that and say this is called A. So show the structure on the board and say this is called A. So there is an input. Input is the vision. What is A looks like goes into our eyes, and she keeps telling that this is called A, so that the voice gets into our ears. So the input is the picture and output was the voice, and the picture through our eyes get to the brain, and some neuron fires. So whenever the structure of A is seen, one component of the brain fires. Same way, whenever we hear the word A or the sound of A through the ears, some part of the brain fires. And when we are learning what A is, how A looks like, how A is pronounced, then one goes to our eyes, the structure, how it looks like, and one part of the brain triggers, and A, the pronunciation, goes to our ears, and another part of the brain triggers. So this is happening together. See A, listen A, see A, listen A, see A, listen A is happening together, and in the brain 2 points are getting triggered simultaneously, and this simultaneous trigger again and again and again and again will tell the brain that these two have some relation among them, and because of that some connection is formed. So forming this connection between two neurons in the brain, one coming from the visual side and one coming from the auditory side, firing together, will make us learn that whenever we see that the voice of A, we imagine or as if we hear it, or whenever we hear the pronunciation of A, suddenly the picture of A comes before us. So this is what we call learning, and in this learning teacher plays a major role. Teacher here we can call a supervisor, and this type of learning is what we call supervised learning. So the examples for our supervised learning in our machine learning case is like house price predictions and all that. A big list of data is given depending on where the house is, what is size of the house, how many bedrooms are there, how many what type of kitchen is there, whether that particular thing has got a garage or not, and all that. So many different items are discussed about a house, and finally its price. So where it is located, how far it is from the highway, all details are listed together. So it's a very big list talking about a property of a house and then its price. So this big table we have, and we as a human cannot understand how they are correlated and all that. So what we can do is we can dump all this data onto the machine and say that the data we have about the house, the property of the house or features of the house, how they are correlated with the price of the house. If you can correlate, then next time when we are trying to purchase a house, we get all these features: where the house is located, what is size of the house, how many bedrooms are there, how many rooms are there, what type of garage we have, and all that. If we dump all this information to our model, it should tell us what is the expected price for that particular house and all. So this type of activity is what we call regression. So there is another type of thing where we can classify whether it belongs to this category or that category. Like we do have a big list of emails with us, and we just say that this type of email is a spam, this type of email is not a spam, and all that. All these are dumped to the machine and say, you try to identify correlation between what makes an email spam and what makes an email not a spam, and then when a new email comes, you just automatically classify it whether it is spam or not. If it is spam, then just forward it to the spam the folder. If it is not spam, then get it to the inbox. So that is supervised learning. Now coming to the second type of learning, which is called unsupervised learning, where the model works with unlabeled data. That means there is no output, there is only input, and we have to find some hidden structures from there. So there's one activity what we can do is identify the hidden structures and put all the objects having similar structures together, which we call clustering. So here you can see from this image that we can see so many different objects. So I don't know whether we should call them flowers or animals or whatever it is, but the moment you look at it, we can identify that there are different types of objects found. So let us say that yes, there are flowers. Okay. So flowers. So there are some flowers which are of yellow type. There are some flowers which are of whitish things. There are some flowers which are of reddish type. Looking at that, we can immediately say that all the flowers which are of yellow colors are of one property. All the flowers here share some other property. All the flowers here share some other property. All these blue color flowers share some other property. In terms of structure, shape, color, fragrance, many features are there. So looking at the features, we can combine all the objects together into one cluster which share these features in common. So we don't have to understand what each object is, what they are called and all that. We don't need any name for them, just we need an input. That image is an input here, and looking at that we can just say that there are some 3-4 types of flowers available here. One is blue flower, one is yellow flower, one is this color flower, one is red flower and all that. So there is one more cluster here, one 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 cluster here. Then you can say that this cluster are similar, this cluster are similar, or this cluster may be similar, and all that. So we are talking about in abstract sense. So we don't have to name them, but just looking at the data, we can just identify the hidden structures or some patterns from that, and then cluster them into different categories, different classes, and all that. That is one type of unsupervised learning, because nobody is there to help us. There is no output given here is what these flowers are called and all that. We are not interested in knowing names of the flowers. What we are interested in features of the flowers, and looking at the features of the flowers, we can classify them into different groups. Same way you can think of other types of objects like animals. You can see there are different types of animals. So many animals are available here, but if you look closely, then we can find that there are some animals which share some common features, and these are one type of animals, these are another type of animal, these are one other type of animals, and we have deers here, we have elephants here, and so on. We can just cluster them into different classes, and that is what is an unsupervised learning. So how do we use the unsupervised learning for our machine learning problems? So we can segment the customers into different classes in the marketing problems, or we can segment the text data into different topics and all that. So we don't have to name them give them any particular name for that, but yes, looking at the features, properties, we can separate them. So that is unsupervised learning. The third case is the reinforcement learning, where an agent learns by interacting with an environment and receiving rewards or penalties. Yeah. Yes, definitely you should remember this. This is when you started learning how to run a bike. So when you are trying to ride a bicycle or a bike, so you didn't do it perfectly on the first instant itself. You did do it perfectly on the first day itself, or even first week. It took a lot of time to understand how to ride it. So to ride this, what are essential requirements are: number one, keep moving. Unless until you don't keep moving, we cannot ride the bike. If we stop moving, we fall down. Second thing is maintaining balance of the handle. So maintaining balance of the handle means if we are tilting towards one side, the handle should be rotated such that automatically opposite tilt is created through the handle. So we should understand that if we are following this side, then handle should be turned to this side, and how much turning is to be done, and all these things have to be made sure while pedaling. If you stop pedaling, the motion will stop, then we fall down and all that. So many things we had to learn, but that cannot be taught by anyone, that cannot be learned by reading books and all that. It has to be personally experienced. And what is this experience is, you just get onto the bike and then start working on it. So first time you don't understand anything, what maintaining the speed is, what maintaining the balance is, and all that. You don't understand anything. Keep falling, keep falling, keep falling, again and again and again. We keep repeating that. Whenever we fall, we realize that we made a mistake, we had an injury, penalty, and for some reason we could move further for some distance without falling. So that gives some happiness, and then we start introspecting ourselves why we could move so long without falling. Then that way we just try to visualize what happened there, what actions I did, so that I could move till that point without falling. And if I can repeat those actions again, then will I stretch my movement for a longer distance. So this is how we went on doing, and anytime we made a mistake, we fell down. So next time we try to avoid making that mistake. So this feedback system, which is giving us reward or penalty, will make us learn. So that is how we learned riding the bicycle, that's how we learn swimming, that's how we learn to play any game, chess or anything. So we have to play, we have to ride, we have to swim, only then we can do it. It's not possible just by reading how to and all that. It has to be experienced personally, and that is what we call reinforcement learning. In our uh, machine learning language, this reinforcement learning can be used to make the robots work on their own. So we train the robots to work on their own, then the same way as we were making a human or a child to ride a bike, we try to teach a robot how to walk. So it has to use something like reinforcement learning, has to make mistakes, has to learn from mistakes, has to do some correct things, learn from correct things. So whenever it does correct things, gets a reward. Whenever it does mistake, gets a penalty. So try to get more and more rewards, try to get less and less penalties. That's what reinforcement learning is. So that's about the three major types of machine learning algorithms. One, supervised learning, where input, output both are there in the data, and the machine is asked to correlate between input and output and create a model. Second one, the unsupervised learning, where only input is given, there is no output. So from the input, some common features have to be identified and clustered into various classes and all that. And the third one is reinforcement learning, where neither input is there nor output is there. The agent is allowed to take some action, and from the action, environment gets disturbed in positive way, then rewards; in negative way, then punishment. And the agent should somehow learn to increase the number of rewards, reduce the number of penalties with time. So we say with time it is learning, it's becoming more and more expert and all that, and that is reinforcement learning. So that's it for now. Thank you. Hi friends, welcome back. Now let us see the key steps involved in a machine learning project, what exactly we have to do when we are building a machine learning project. So let's see what are the steps to follow. So the first step is to collect the data. Data is the foundation of any machine learning system. So the first step in any machine learning project is to collect the data. So the data may be collected in various ways. It can be collected through forms and questionnaires, maybe through conducting interviews, or maybe by observation, or from the documents and the records we can collect it, or we can collect it from oral histories, can be collected from combination research, online tracking, online marketing analysis, social media monitoring and all that. So there are many ways of collecting it. So basically there are two ways of collecting data, or two types of data we can say, to be exact. One is called the primary data, other one is called the secondary data. The primary data is the one which we collect ourselves for our project. So that is whatever data we require for our project, or to solve our problem, whatever data we require, if we collect ourselves, then it forms a primary data. That means it's a data that is perfectly suited for our purpose. So exactly what we want, we keep searching all around and collect that, and that's a primary data. And advantage is what exactly you want is available with that. But the other side of drawback is that it is costly, it is time consuming, and a lot of resources are required and all that. So it's time consuming, and we should have a proper plan to collect the data and all that. So that's one side. On the other side, we have secondary data, where someone else has collected data for their purpose, and if that data can serve our purpose, then we can borrow that data from them and use it. So yes, that is secondary data. We don't have to run around for collecting the data. Somebody else has already done that, taken pains to collect the data and put them in one place. So we just have to borrow from them, maybe with a fees or freely and all that, depending on from whom we are borrowing and all that. Whatever it is, yes, availability of the data is very easy. But the only problem with that data is it may not be tailor-made to our problem. So it is the data they have collected to solve their problem. So it may not be totally convenient to use as it is as per our requirement. So we need to modify or tailor-make to our requirements. So that is what the secondary data is. Whatever it is, we have to first collect the data. That is the first step we have to take up. And once the data is collected, we are not sure that the data is in proper form, proper shape and all that. Some data may be missing, some data may have error, some data may be out of the range, and something maybe different types of errors and all that. So we need to make sure that our data is clean. So we have to clean the data, then check that the data is within the range. So usually we normalize each input so that it is within the range. So the different inputs are of same range, so that they don't supersede the presence of other one and all that. So if one input is in one cents and all that, and if another input is in thousands and all that, so the variation in thousands can hide this variation in ones and twos of another input. So the variation, the parameter which is varying in terms of thousands may not allow the variation or the parameter which is varying in ones or tens to be visible in the overall global scenario. So to make sure that each one is equally visible, we need to normalize them. So sometime the direct data may not be useful, so we need to modify the data. We want to transform it to another form so that it becomes easier for us to use the data, to work with the data and all that. So some features we need to extract from the data, so feature engineering is required. And some cases the data may not be in balance. That means when you are talking about classification type of problem, then one class, the data belonging to one class may be in very large number, and the other data belonging to another class may be of very small size, and this imbalance in the size will definitely will not allow the balanced machine to be created. So there will be a bias, and this bias has to be removed. So to make sure that such bias doesn't exist, so we need to ensure that there is no imbalance in the data. Somehow try to balance the data, either reduce the number of data which you are having more in number, or somehow try to increase the number of data of the class where the number were fewer in the beginning and all that. So that's what we need to do before actually getting into work. So make sure that the data is perfectly all right, only then get to the next step. The next step is to create a model, choose a model. So this model can be a decision tree or neural network, support vector machine, and many more. So just looking at the type of the data we have. So does the data has got any response? If yes, then we are talking about something like supervised learning, that is input output both are there. So the input is there and its response is also there, then input output both are there, and then we are talking about supervised learning. And in supervised learning, if the predicting value is a numeric one, then we are working with regression, or if it is a categorical, then we are working with the classification. On the other side, if we don't have any response, then we are working with unsupervised learning, and this unsupervised learning again will be either clustering or dimensionality reduction. So just look at, are you looking for dimensionality reduction? If yes, then go for dimensionality reduction type of unsupervised learning. Otherwise you just go for clustering. So that's what is to be done. Next is to choose an appropriate model depending on the type of data we have and type of the response we are expecting from our model. And once that is done, then this model should be trained with the available data. And this training is done through feeding the training data to our model so that our model can learn the patterns hidden in the data, and this learning of the pattern is what we call training the model. And once the model is trained, then we need to verify whether the training is successful or not. So we need to evaluate the performance of the model. So test with some unforeseen data and then look for accuracy, precision, recall, F1 score, etc. So it can be done through what we call a confusion matrix, which is shown here. So that confusion matrix can be used for computing the accuracy, precision, recall, and finally precision and recall together can be used to calculate the F score. So this evaluation performance is done, and once we are happy with the performance of this model we have created, then what else? Just deploy it. So deploy it and start using in the real world applications and keep refining it. So use it, give new inputs, check the output, and these input output combinations you feedback, check the performance, evaluate the performance of this newly generated outputs and see how better your model is performing. If you find that the model performance is deteriorating, then we need to refine the model, retrain the model, add new inputs to the data set, and then again retrain it and all that. So these are the key steps involved in machine learning project. So let me recall that. So collect the data, then pre-process the data, then choose a model, train the model, evaluate the performance of the model, and finally deploy it and use it. So that's it about the machine learning project steps involved. So this is Sandeep signing off for this session. Thank you. Hi everyone, welcome back. Now let us see the common implementation of machine learning algorithms. So for implementing any machine learning algorithm, what we require is a platform. A better platform can be a Python. There are many platforms, but Python is one of the better platforms available for implementing any machine learning solutions. So over the Python, we do have a layer called TensorFlow that helps in implementing the machine learning codes, machine learning algorithms, and we have Keras over that, and this will help us in building neural networks and ready-made models available for fine-tuning and all that. So let's look them in detail one by one. So starting with Python. Why do we require Python? It's easy to learn and simple. Python has a simple readable syntax, almost close to English, whereas in other languages like C, C++, Java and all that, most of the syntax based things are there, so which has too much of syntax and not very easily readable, and whereas Python is easily readable because the instructions of Python are almost like English. So the beginners can focus more on machine learning concepts rather than struggling for the complex programming details like the opening the brace, closing the brace and all such issues. Then about the syntax, about the various aspects of programming language. Too complex issues are there that steal most of our time in writing the code, and very less time is available for implementing what actually we wanted, that is a machine learning component. So for example, building a neural network in Python takes only a few lines when you compare with Java and all that. So it takes some pages of program to write a neural network and all that. But in Python, with just a few lines are sufficient to solve this problem. The next thing is we have a very rich ecosystem of libraries along with the Python that will help us simplify our work, and we can just depend on these libraries which are very rich in their performance. So this has got a very huge collection of machine learning and data science libraries specifically created for machine learning activities, data science activities, where a lot of libraries are available along with the Python. So that simplifies most of our work. So we don't have to write code for every algorithm. Algorithms are already coded in these libraries, and we just have to use them, just call their names and use them so as a function. So most of the activities are simple. So example, you have NumPy, SciPy. So these are useful for numerical computing and scientific computing respectively. So we do have huge libraries like NumPy. So NumPy has got many instructions that are useful for numeric computation, whereas SciPy has got a lot of instructions available for scientific computing and all that. If we are talking about big data, the data is available in the tables, other data sources and all that. Then importing, exporting the data, working with the data, manipulating the data and all that is made convenient through the library called Pandas. Then yes, without visualizing the data, it is not possible to understand what the information data is trying to give us. Only until we put that in the pictorial form, we will not be able to understand what are the relationship between the various components of the data and all that. So that is possible only when we plot them. So for plotting, we have excellent tools under Matplotlib and Seaborn and all that. So we have very excellent tools for visualizing the data, and that is possible only through Python. And then we have a big library of ML algorithms under scikit-learn. So under scikit-learn, we have a big set of classic machine learning algorithms available. You just have to name them, you don't have to define anything. So just take the data and the model is directly created by using these ML tools, algorithms which are under scikit-learn. And then of course TensorFlow, PyTorch, Keras are very much useful when it goes for a higher complexity of the problems like deep learning and all that. These are going to help us, and these are possible only through Python. Therefore Python is a better choice for any machine learning engineer, because it provides a wonderful ecosystem of libraries for simplifying our activity. So these ready-made tools save time and effort, so we don't have to worry much about that. Just I have to decide, should I use this algorithm or that algorithm. So once I know that I should use this algorithm, just name it, and you have that available through Scikit, TensorFlow, Keras and all that. Just use them and solve your problem. And of course there is a strong community support we have. So if we are not able to understand anything, just talk to the community. So millions of developers and researchers are using Python, and they have a common platform to interact with each other, and tons of tutorials, documentation, GitHub projects and forums are available for Python. So if I am interested in working in Python, I just begin with some tutorials, get the documents, and if I want to know how a project can be initiated, how project can be built, instead of understanding everything from the scratch, let me take some already created project which is available on the GitHub, and just get a copy of that and try to see it, understand it, and then manipulate that and try to understand how that whole thing is created and all that. And there are many forums which we can interact, and if I feel some problems, if I am not able to solve my problem, I just post my problem onto the forum, and someone will be happy to answer my queries. So there is a big community available, which are strongly supporting us for all these So lot of things available. Don't have to depend only on some textbooks or anything. So whole world is available for us for giving their support. So that's the advantage of working with Python. And easy to debug, faster debug, and hence the learning curve is easier, faster. Then integration and flexibility, so can easily integrate with the C or C++ for speed critical parts. So whenever we have to work on ground level, like work at the machine level, then instead of writing Python code, we can write simple C or C++ code and then integrate that with our Python code. So wherever we want to make sure that we want to work at ground level, at machine level, then we can write a C program, or even sometime if possible then we can write assembly programs and integrate with our Python code. It works with the web frameworks like Flask, Django for deployment of machine learning models, compatible with big data tools like Spark, Hadoop and all that. So it is directly compatible with that, because when you are working on machine learning, definitely we do require data. From where should I get the data? The data should be available somewhere on the internet, and I need to get the data. So it's a big data we have. Then for getting the big data, we need some big data tools like Hadoop, all that. So it is easily compatible. Python is easily compatible with Hadoop and all that. So we don't have to do much circus to connect Hadoop with our codes and all that. It's directly compatible. Then it is platform independence. That's the most important thing. What we talk about is we don't know what platform we are going to use. So it may be Windows, Linux, Mac OS, cloud, by mobile, anywhere you can use it. So you just write a code in Python. So the same code can be run on Windows, Linux, Mac, cloud, mobile devices, anywhere it can run. So that's another greatest advantage of working with Python. So don't have to worry much about when you are trying to change the platform from one platform to another platform, or if multiple people are working together for a particular cause, each one may be using different platforms. That here doesn't make any difference, because the whole Python itself is platform independent. So I can create a part of the code in Windows and then forward it to another one who is now working on Linux. So he just takes my Python code and starts working on this Linux system and all that. It doesn't make any difference. I don't have to convert this code which was working on Windows compatible to the code which should run on Linux and all that. Nothing of that sort is required. Just take it, put it, use it. That's easy we have. So code can be easily shared, reproduced across the platforms without much modification. Don't need to modify because it is independent of that. Then visualization and data handling is very easy in Python. And machine learning mainly depends heavily on the data understanding. Unless until you understand the data, we will not be able to create a machine learning system. So to understand the data, just looking at the table, millions of rows, thousands of columns or hundreds of columns, all filled with numbers or something. Just look at that. It's a big ocean. We can't make out anything unless until you put it in some graphical way. So that is most important. So visualization is the most important tool we do have to understand the data. Only after understanding the data we can go for what model to build, how to work with data, and how ML system can be built and all that. So that is possible because Python has got all the visualization data handling tools, and Python provides excellent tools to visualize the trends, patterns. So these visualization tools are Matplotlib, Seaborn, Plotly and all that. So there are many such tools available, and these tools are so strong that in a simple one or few lines of codes you can create wonders. Look at the whole big world of data put on one dashboard. You can just assimilate all the information about the data onto one screen, and that is possible only through visualization tools. And very happy to claim that Python has got a very strong visualization tools with it. So that's why the Python is required for that. And it's definitely an industry and research standard. Python is the default language for AI ML research and the industry. So major companies like Google, Meta, Microsoft, Amazon, Tesla all use the Python for their ML solutions. So in short, if I want to say that Python is popular for machine learning because of its easy, powerful, flexible, and has a huge ecosystem of libraries that make experimenting and deploying the models fast and easy. So that's something about Python, introduction to Python, why Python has become so strong in the AI/ML world. So these are few details or a few aspects where Python wins the race in the AI/ML world. So that's as of now, that's it about the Python. The next in this series, let's see what can be done in the next level, which we call the TensorFlow. So as of now, signing off. Thank you. Hi friends, welcome back. Now let's see what TensorFlow is all about. So TensorFlow is an open source machine learning framework developed by Google Brain team. It is mainly used to build, train and deploy machine learning and deep learning models. So whenever we want to work with data, we need a machine. So we need to make machine learn from the data. So for that, we build a model, we need to train the model, and finally need to deploy the model. So for all these activities, the TensorFlow will be very much useful. It is tailor-made for all these activities. If we are working with TensorFlow, all these activities are very easy to implement. So the name TensorFlow comes from two words. One, tensor. Tensor is a general a multi-dimensional array, the way data is represented in machine learning. So dimension. So a scalar is a 0-dimension data, vector is 1-dimension data, matrix is 2-dimension data, a cube is a 3-dimension data. On same grounds, when we are talking about the data set having n columns, each column is an input, and each of these inputs, if we want to present in the space, data space, then each of these columns will represent one axis. So if we are talking of one column data, then it is one axis, it can be represented as a vector. If there are two column data, then it becomes a matrix. If it's a 3-column data, then it becomes a cube. So that way, so in general, when we talk about n column data, then we are dealing with a space or the data space with n dimensions. So n dimensions data space, instead of talking in particular name for each size array like scalar, vector, matrix, instead of calling this way, we can say in general a tensor. It can be a scalar, it can be a vector, it can be a matrix, it can be anything. In general, n-dimensional data is a tensor. And next is the flow. Here it says how the data moves through our operations. So what are the various operations performed? So first what happens, then what happens, then what happens, then what happens, and all that. So there is a sequence of actions which we want to perform on our data, and to represent that sequence of operations, we make use of something called a flow. So the data, which is in the form of tensors, will flow through our operations pipeline, and hence we call it a TensorFlow. So that's a TensorFlow. Well, why do we require TensorFlow? That's next question anybody can answer it, ask it, and the answer to that is the flexibility. So it can run on CPUs, it can run on GPUs, it can run on TPUs, mobile devices, and the cloud. Anywhere we can work with TensorFlow. What is TPU? TPU is a tensor processing unit, GPU graphic processing unit, CPU central processing unit. Central processing unit is a simple machine where it works with a simpler data. When we want to work with graphical data, then we have a separate processors called graphic processing unit, GPUs. On the same grounds, when we are working with multi-dimensional data, then instead of working on CPUs, and most of the manipulations are done in the user mode, then definitely it is going to be highly time consuming. Instead of working in user mode, if we could somehow make sure that everything is done within a processor, and that too in a kernel mode, then this multidimensional computations and all can be done at a lightning speed, and that is the logic behind construction of the tensor processing units, TPUs. So it is when we work with TensorFlow, it is flexible. We can run on any of these systems. And then it provides a wonderful ecosystem. It provides libraries for deep learning, computer vision, natural language processing, reinforcement learning, and all. So a wonderful ecosystem is provided, and any type of AI related problems can be comfortably solved through TensorFlow. So that's other reason why we go for TensorFlow. Then scalable. So when we are working with scalable, so it supports both small research models as well as a large scale production systems. So it's not that there are some tools which work only for small models. There are tools which work only for large scale production systems and all, but TensorFlow is the one which is scalable from smallest possible model to the biggest possible model. Anything we can work on with TensorFlow. Therefore, it doesn't you don't have to have a different methods for solving different size problems. So you can just be comfortable with one TensorFlow. If you are comfortable with working with TensorFlow, then be it a small problem, medium problem, large problem, any problem can be comfortably solved with the same logic and all that. Yes, community support is most important in today's life, because everything is developing in such a lightning speed. The technology is expanding at a lightning speed that it is almost impossible to cope up with the speed with which technology is growing and all that. So it is almost impossible to know by a single person everything we want. So whenever we have an idea, whenever we come across a problem, and when we sit to solve a problem, we get an idea how we can solve it, but we don't know what resources to use and how to use and all that. That time this community will come to our help. Just we can post our problems to the community we have, and many will help us. So the help from the community may be in the form of tutorials, or we have pre-trained models available. So we can make use of the available pre-trained models. So some people have sit together, spend their important part of their lives in collecting the data and training the model and all that, and that model is available. And if I can use that model and just fine tune that model, then I can reuse that model for my problem. So to solve my problem, I can make use of that. So that is another advantage. So the community is providing us all the pre-trained models and all that. They are providing us tutorials, and even there are places where I can post my questions, and there are some people who are always ready to help us answering our queries, giving us solutions, giving us code, giving us ideas how to implement, what to implement. And if I get stuck somewhere, then there are people who can pull me out of where I am stuck, and they are providing me guidance and all that. So a lot of support we do have from the community when we are working on TensorFlow. This type of support and all was not available in previous era when we were working with C or C++ like. So with TensorFlow we do have that advantage. The key features of TensorFlow, if you want to look at it, then it can be easily integrated with Keras. So about Keras, we look in our next session. So Keras is easy to use high-level API for building neural networks. So the neural networks are one of the core ideas in building the machine learning models. So when you are working with neural networks, so directly we can start working with neural networks, or there are high level APIs available under Keras umbrella. So we can make use of those high level APIs which are readily available for using the neural networks to solve our problem. So it is quite easy to integrate with the Keras. There we have something like TensorBoard, which is a visualization tool for model training. So it just we can just visualize the loss curves, the accuracy, etc., by just modifying the things. The TensorBoard is an interactive tool where we can modify the inputs and check the output and see how the whole thing is working. So we get a very good idea about how the machine learning actually happens and all that. So through tensor boards we can have all this understanding. Then of course pre-trained models are available through TensorFlow Hub, like image classification, NLP embeddings and all that. Now the question comes here is, how does it help us? So somebody has tried to solve their own problem. Yeah, somebody has tried to classify images, and that one who has solved to classify images, maybe classifying flowers. Fine, no problem. So flowers, for the human, that image is flower, but in reality what the data is a set of numbers only. So whether you talk about an image of flower, image of an animal, image of any other thing, it is just a matter of set of numbers. And when we are training a model to classify images of flowers and all that, then what exactly we are giving in to the model is numbers. And if I try to classify animals using this model which was trained to classify flowers, I don't know whether it works or not, but yes, I just blindly try to give input of animals to that. So flower and animal are the things known to the humans, but at the end what goes into machine, whether you call it flower image or you call it a animal image, what goes into machine is a set of numbers. Uh, what do you say, a tensor of numbers just get into the machine, and that tensor of numbers, when we have given for an image, that number may match for some particular flower. Say imagine that we are giving a set of images which is consisting of dogs, and consistently if it happens that whenever we show dog to our model, the rose gets highlighted, it says that the input is rose. So every time we give input of dog, then the output comes is rose. If it is happening consistently, then what we can do is simply change the label, instead of rose write dog. As simple as that. That is what the idea behind pre-trained model, because this era is not to start anything from the scratch. It is, the era is reusability. Whatever past generation has created, instead of starting everything again from scratch, why not start building from there where they had left it? So whatever they have done till then, okay, done, it is their contribution. From there let us continue. So that way we can create new and new, more and more complex things, because we don't have to build all the basics, it is already done. Now I have to build one step ahead of that, so I can think of my new problem, and because of that uh, we are now able to think of solving bigger and bigger problems. A few decades back, when this machine learning concept was not in fully working mode, then the extracting features were done manually. That is, we have to write a code for extracting features, and connecting the features together we could be able to understand what the object is and all that. So that was a big circus we had to do earlier. Today, thanks to machines learning, thanks to the data availability and all that, so we are able to solve that. So now I can make use of this pre-trained model, because when you are talking about pre-trained model, so there are some models which are built by big companies, and they have spent say thousands of machines working in parallel and used some billions of data for training, and all this work they have done for some months together, and they could create one model. And if we want to do it at our level, then it is not possible in anyone's lifetime. So the best option, reuse that model. And thanks to the open source mindset of today's generation, whatever we do, we just put it on the open source platform. They are available on open source, so I can get that model and just look for, will that model solve my problem? If it can solve my problem, directly use it. If it cannot solve my problem, okay, no problem, small fine tuning if it is required. Then with small fine tuning, if I can solve my problem, I don't have to work on collection of the data, I don't have to work on training the model and all that. I don't have to spend months or years to train a model and all that. It is already done by some great group of people. So thanks to them, thanks to open source, these pre-trained models are available. Use them and think adding new features to whatever is available today, so that way we can build our research activities more and more faster. Yes, cross-platform is another feature of TensorFlow. Works on desktop, cloud, mobile, edge devices and all that. So you don't have to worry at all. So most of us are now are happy working on our mobile phones, because on mobile phones also our TensorFlows and all that are easily available. So don't have to uh, think of having a system with all that requirement, minimum requirements and all that. So all that has gone, or you can just depend everything on the cloud. Don't have to have any resources, just work on the cloud. So your resources are available on the cloud, data is available on the cloud. Just you put your ideas there and get the results out. So cross-platform is another advantage of working with this TensorFlow. Looking at some applications of TensorFlow, image recognition, can be natural language processing. So while creating chatbots, translations, sentiment analysis and all that can be more comfortably done through TensorFlow than working directly at Python level. So at Python level it is quite difficult to have these ideas come to reality, but thanks to TensorFlow, it has made most of the ideas to be possible in real time. The speech recognition, yes, today's world works totally on the speech recognition, so you don't have to keep typing everything. You can just keep on telling what you want to do and all that. Just give commands orally and your systems are ready to work for you. Time series forecasting and all that is a very wonderful tool we have for better, faster, accurate predictions about the stock prices, weather and all that. So any time series forecasting we can very comfortably do with the TensorFlow. Healthcare, yeah, so any diseases and all can be easily detected and all that through scans. So we can use TensorFlow to create the models. The models are created through what we call supervised learning, and this supervised learning we make use of the data, and this data comes from the experts. The domain experts will give this data. That means they have seen these images, and from the images they say that there is a disease or there is no disease, and all this data we collect, and the images along with the labels provided by the domain experts. We just dump onto the machine, and here the TensorFlow will help us in making the learning and making decisions much faster because of the tensor processing units and this TensorFlow activity and all that. So that makes the things quite interesting and very fast. So through TensorFlow we do have lot of applications, lot of problems solved in real time, which sometime back were totally unrealistic. Nobody dare to think how to solve that. Nobody dare to solve them because it could take more than a person's lifetime. So nobody used to think of solving such problems. But through TensorFlow, it has become possible. So that's some details about TensorFlow. Hi, this is Sandeep signing off as of now. Let's meet in next session, more details about Keras. So that's it for now. Thank you. Hi friends, welcome back. Now let us see what Keras is all about. In the previous sessions we have seen how Python is helpful in machine learning. Then on the Python we had another layer, TensorFlow, and the TensorFlow created or offered the machine learning algorithms, model building and all facilities. Now on top of TensorFlow we have another layer which is Keras. So what is Keras? It's an open source high level neural network API written in Python. So Keras is a high level API, and that is mainly written for neural networks, and most importantly it is written in Python, and even more important is it is open source. Anybody can use it freely. So that's one important aspect of Keras. It's mainly defined for neural networks, and when we are working with the data, and especially with the labeled data, and when we are working by supervised learning, creating a model, so the most efficient model, most appropriate model would be a neural network. And when we are working with neural network, we had to do a lot of exercise like training, and while training usually we do use backpropagation method and all that. So if we are working in Python and all that, this all training functionalities we had to define ourselves. But once we are with Keras, we don't have to worry anymore about the training and all that. It just comes with Keras. So all the data is just we need to dump to the machine and say learn. So the life has become so easy with Python, TensorFlow and Keras that we have very least work to do, that is collect the data, give the data to the machine and ask machine to learn, and that is the advantage of today's era. So it runs on top of TensorFlow, and TensorFlow is working on top of Python. So the main goal of Keras is to make deep learning easier and faster to build. So when we are talking about neural networks, so the old neural networks were having only two layers, input layer, output layer, and the functionality was very poor, and the efficiency was very poor, and the applications which was used for was very simple ones. But when we wanted to work with bigger and bigger problems, then definitely we wanted a better model, and for that we need more than two layers, so one input layer and one output layer, and in between we wanted many hidden layers. So the moment the hidden layers come into picture, then the common name we give is deep learning. Otherwise, it's just a machine learning only, but deep learning is a special case of machine learning where we are using a neural network with more than two layers, input layer, output layer, and many hidden layers. Then we call it deep learning. So as the number of layers increase, then the number of neurons will increase. As the number of neurons increase, the number of weights will increase exponentially, and finding the correct values of these weights is what we call training. And this training does not happen in one step. It has to be done on an iterative basis, and again and again and again has to be repeated. And through Keras, these operations have become simpler, and these operations are done more faster, and hence now the deep learning has become a reality only because of Keras. So without Keras, deep learning was beyond our thoughts. So you think of TensorFlow as a powerful engine, then Keras will be a friendly driver's dashboard that makes using the engine much simpler. So that's the main working force is the TensorFlow, but Keras creates a proper dashboard so that for the user it becomes simpler to understand what to do, when to do, how to do, and all that. So we get a easier, clearer picture of what exactly we are trying to do if we have a lens of Keras. So we see through the Keras and through the TensorFlow, then the Python can be implemented at a very large scale, and hence a bigger problem can be comfortably, easily solved. So why do we require Keras? On the first hand, it is user friendly, it is very simple, consistent APIs are available, so easy to learn for the beginner. So we don't have to worry much about what exactly happens inside. We just have to worry about how to use them. So it is very easy for anybody to learn how to use any device or anything than understanding how the device was built, how it was designed, how it was created, and all that. It is easier for us to understand how to use any device. So that is what Keras is trying to do. Instead of understanding what to do, just if we use Keras, then we just have to know what to do, how to do, and all that. We don't have to worry at all. And the size of the code is so small now that within few lines we can create a greater wonders and all that. And it is modular, so we can build the models layer by layer and stacking one upon other. And this way, if any time we want to modify, then only one layer has to be updated. Don't have to worry about the whole system. So that makes life even simpler. And the prototyping is very fast with Keras. So it's great for research and quick experimentation. So when we are doing some research, we are in a hurry to get some results. So whether we wanted to know whether our ideas really work or not. So when we are in a hurry to know our ideas worth and all that, Keras is the best solution for us to get it implemented, do the experiments as quickly and get the results and know the worthiness of our idea. And very easy to integrate with the TensorFlow. There we said that it is easy to integrate with the Keras on the same way. The other way is also true. Very easy to interface with the TensorFlow, so work seamlessly with TensorFlow's advanced features. So looking at the applications of the Keras, so image classifications, mainly the convolutional neural networks are a big boon in machine learning, in computer vision, for whether it is image classification or video processing or any such thing. These CNNs are a big boon, and this is possible only through Keras. Natural language processing is another important area where we are making a lot of development through recurrent neural networks, transformers, and all that. So this natural language processing will help us in interacting with the machines orally. We don't have to write the program, we don't have to type anything, we just have to tell machine what to do, and in our natural language what we want some work to be done, just we tell to the machine that do this, and the machine should understand what we are telling exactly, and once it understands exactly what we are telling, then it can continue acting upon it. But to understand humans language itself is almost next to impossible, because there are many constraints we have. One is about the way each one talks, the other way the pronunciation problems, language problems, grammatical mistakes, many issues are related with that. So it has to deal with all these constraints and come out with a successful results. So this big task is achievable today only because of Keras. Time series forecasting, yes, of course, for understanding the pattern in time series, we need a lot of data in the time series, and to work with all the data, we need a big processing, and that processing is made possible only through Keras. Of course, reinforcement learning is possible only through Keras with the integration of TensorFlow and all that. So reinforcement learning is something which we admire too in the field of machine learning, that we just want a machine to learn by itself as we human learn to talk, to walk, and to understand the situation and give a solution and all that. So whatever intelligence we have, we want to give that intelligence to the machine, though it cannot be a natural intelligence, so we call it artificial intelligence. Want to make machine as intelligent as humans, and that is possible only if we imitate how human learn and make machine also learn the way humans learn, and that process is what we call reinforcement learning. So that's some details about Keras. So any machine learning project is incomplete without Python, without TensorFlow, without Keras. So these three are main pillars, put one over other. At the bottom we have Python, on the next layer we have TensorFlow, above it we have Keras. All these three things together make any ML developer's life much easier, exponentially reduced the complexity of our problem. So thanks to Python, thanks to TensorFlow, thanks to Keras, and all the people who are working in this open source world, and helping all the newcomers, welcoming the newcomers with all the resources they have, training them, giving documents, and all that. So that's about Keras. So this is Sandeep signing off for this session. Thank you. Bye. Hi friends, welcome back. Now let us look at what the transfer learning is all about. Transfer learning is a machine learning technique where a model trained on one task is reused as the starting point for a different but some related task. Now how does this matter? A machine is trained for a particular task. So for a human it is a particular task, but for a machine, when it comes, it's all numbers. Input is a number, output is a number. So for example, if we have defined or designed a machine learning model that is to distinguish between various categories of flowers, then we have trained this model using multiple images, many images of various categories of flowers, and each category consisting of many images and all that. And if this is done by a big organization, then it has got a lot of resources, so thousands of systems it can make run parallelly, and with all that, thousands of machines working in parallelly, learning to differentiate between the various categories of the flowers. It might have taken some months to train with billions of images and all that. So for a big organization, having a big setup may not be a big issue. Collecting billions of images also may not be an issue, and running all the algorithm in parallel may not be a big issue. Waiting for months together may not be a big issue, and with all that they have created one model. And this model accepts various flower images and finally tells what category of the flower it belongs to. Good. But what actually is happening is the image of the flower is only a flower when it is viewed by the human on a screen. But in reality, when you say an image is just a file. A file is made up of some tensor, a set of numbers in 2D if it is a monochrome image or gray image, or 3D if it is a color image, or 4D if it is a video, and so on. So whatever it is, it's just a tensor, a group of numbers, and this group of numbers is fed in and said that this group of numbers means it is a rose, this group of numbers means it is a lily, like that it was trained. Done. So we have that model available, and thanks to today's open source way of working, so nobody wants to keep their secrets with them, they want to share with the whole world. And because of this open source culture, the model which was trained with billions of flower images is made available openly through open source. Say I try to use this model and start giving images of the, say, animals. Yeah, again it is flower or animal is under the context of human vision. When human views that image or that data as image on the screen, then the human identifies whether the object is a dog or a flower and all that. But for a model, it's just a tensor of numbers, whether it is a flower image or a dog image or a cat image or an elephant image, whatever it is. So at the end, what the machine is doing is taking a tensor of numbers and giving an output in the form of again numbers. And let us try using a model that was trained for flowers and try to give images of animals. Let us see what could happen. So dog and cat and all that are just our version, but at the end what goes into machine is again set of numbers, a tensor of numbers. Done. A tensor of numbers, say for a dog we have given in, and the machine looking at those numbers may think that it is rose, says rose. Show another dog, if it feels that it is rose, it will say rose. So that way keep on showing dog, and if it keeps on saying rose consistently, then what we can do is just change the label. Instead of rose, put a label of dog. So that's as simple as that. So what we can do is reusability. So today's mantra is reusability. You don't have to create everything from scratch. Whatever is available, try to use it. And if I want to use it, I don't have that big network, I don't have that big facility, I don't have that huge number of inputs and all that to train. Even I don't have that infrastructure that I can complete training process in month. If I try to work with my machine, then whatever happened with the big infrastructure in months, it may take more than lifetime and all that. So that's not physically possible. But yes, they made it possible through open source. So their model is made available to us, and if I want to use that and give my input to that, then if it starts some consistent output, like for every time dog is shown it says Rose, every time cat is shown it says Lily, like that, if it happens consistently, then I can just change the labels and use the model without any problem. That is the concept of transfer learning. So reuse a model from where we stopped, start from there. So just fine tune the model. So instead of training the whole model, so we usually talk about model as a neural network having layers, or tens of layers, 50s of layers, hundreds of layers, sometimes more than hundreds of layers are there. So when you're talking of hundreds of layers of neural network, then billions of or millions of weights are there which are to be adjusted during training process, and that's what takes large amount of time. And somebody has already done this exercise and that model is created, that means all the weights are available. But if it is not perfectly matching with what we wanted, what we can do is the last layer, keep it open, all other layers just freeze the weights as it was earlier, just modify last layer, just fine tune the last layer weights. So with the simple fine tuning, if we can get our work done, that's it. So that is the concept of transfer learning. So here, instead of training a model from the scratch, we transfer knowledge from already trained model. That's what we was talking. So a model was able to identify the flowers. Now the same thing, if I can use for animals, nothing more than that. That is the concept of transfer learning. So think of it as using what you already know in one subject to help you to learn another one. So that way you can think of. So what is the need for transfer learning? It saves lot of time. So training deep models from scratch take huge data and too much of computing power. As I said, if this is done by a bigger company like Google or Met and all that, so they have big infrastructure with them, they have big workforce, they have so much that they can collect huge data, they can have a lot of computing facilities, so they can use months together to train it, but that's not possible for every individual. So make use of that instead of starting from scratch. Make use of that available model. So that's going to save a lot of time. So if you want to know in absolute sense, then what actual training from scratch could be done in years, if that is available, then the same model retraining or fine tuning it may take few seconds or few minutes to solve the problem. So much of time saving we have because of this, what we call transfer learning. Accuracy, yes, definitely. They have used billions of images for training. They have used a big platform for training and all that. Lot of time they have invested on training, and definitely we have built a wonderful model. Just a minor fine tuning can solve our problem. Therefore, the best possible accuracy is possible through transfer learning instead of starting everything from scratch. It is almost next to impossible to get anything in real time, and that too with the best possible accuracy. And definitely when it is we doing it, the data set we have will be usually limited in size, and if we try to train any model, then it is not possible, and then therefore our model will not be properly built, and hence our uh, whole work goes waste, because it doesn't make much sense because of small data set available, training and all that will not be efficient. So best would be transfer learning. How does it work? So pre-train a model on a large data set, just like I just said. So like an example, ImageNet is with millions of images is created. So we do have something like ImageNet, ResNet and all that. So pre-trained models are available, and thanks to open source culture, they are available for free usage. Anybody can use it. And what else? What else you require? Just use them. Transfer the learned features, edges, shapes, patterns to a new task, whatever you are talking about. Just transfer these new learned features to a new task and get the work done. So for getting it perfectly done, so fine tune only some few last layers to fit to the target problem. So we have talking about a data having thousands of categories, and with 1,000 categories data model was made available. Now we are not going to work with 1,000 category data, so we may have data with 10 category data, and I can just fine tune the last layer. Instead of having 1,000 outputs, I can just converge to only 10 outputs, and only the last layer weights I can modify while training, and that way fine tune it and get the target problem to be solved. So for example, deep learning model trained of millions of general images like dog, cars, trees are available. So we can build a model for detecting pneumonia from the X-ray images. So yes, so we have a model which is trying to identify objects of general thing like dogs, cars, trees, streets, animals and all that. But nowhere our data set was having X-ray images or CT scan images or any such thing. Then if we start giving these X-ray images and all that, and if it somewhere solves our problem accidentally, because at the end, whether you talk about image of animal, dog or anything, or talk about image of X-ray, what goes in is just a tensor of numbers. A tensor goes in, tensor comes out, and that tensor may be anything. It's only the human who is going to decide what it is. The meaning of the tensor, it is only the context based. If the images human thinks are of the having objects like cats, dogs and all that, then it is cats, dogs. If the human thinks that this is an X-ray for pneumonia or something like bone fracture or something, then it is about that. If human thinks that it is a CT scan for brain tumor identification, and okay, that is that. But at the end, what goes into the model is a tensor. What comes out of model is a tensor. What you name it, what names you give for input, what names you give for output is all human based, and that just labeling, change of label solves the whole problem. So that's a way we can use the model used for detecting dogs, trees, cars, etc. to identify whether the chest X-ray image contains any symptoms of pneumonia or so. So instead of starting from scratch, we can take a pre-trained model like ResNet, VGG, fine-tune it with medical images. So that's what we are talking about. So now we have already this ResNet or VGG models are available. So take that, just change the last one layer, keep it trainable, rest all thing, freeze the weights, then start giving the images of chest X-rays and say this has pneumonia, this doesn't has pneumonia, this has a pneumonia, this doesn't have pneumonia. So train that, only the last layer gets adjusted. With the least efforts, with minimum training time, we can get the best result out of it. So that is the power of transfer learning. So with the transfer learning using such models, we can get a high accuracy with less data and minimum training time. So application of transfer learning, computer vision, so image classification, object detection, medical imaging, we name anything in computer vision. a best way to do is use transfer learning. Many models are available on the open source under Keras, under TensorFlow. Many models are available. Just make use of them. Just fine tune according to your problem, get your problem solved. Natural language processing, yes, another important thing, because today our laziness is not allowing us to type anything. At the end, I want to just instruct to my machine that there are images there, just look at that and tell me what image contains and all that. So I just want to talk to my machine as if I am talking to a learned human and all that, and ask my computer to solve my problem. So there comes the natural language processing. So these all transfer learning can be very much helpful there. So one model is available, then make use for any other. Speech recognition is another thing. So adapting general speech models to specific accents, domains, etc. Because when you are trying to train, so every 50 kilometer you travel, the way people speak changes, the languages change, the way people speak change, even though it is called the same language, name of the language is same, you just say English only, but every 50 kilometer you travel across any place, the way each word is pronounced, the way the sentences are formed are so typical that you can't just make anything universally possible. So need more intelligent way of doing that. So instead of starting anything from scratch, if any such thing is available, then just make fine tuning that if it is working for say British accent, then how those words are pronounced in America. If you just connect them, then now your machine is now ready to accept the American accent and all that. Same way any other thing. So makes our life quite simple because of transfer learning. So at the end, let me look at a few applications of whatever we have learned here in the machine learning. It's the best way to work with healthcare, like the disease prediction, drug discovery, and all that. Because mainly we are talking about the programming and all that. So we want to create a software, and those who are creating software are definitely don't have any domain knowledge about healthcare and all that. So it is not possible to understand the whole domain and then create a code for that. Instead of that, we can just try to copy their behavior through machine learning, and that way lot of development is done now in healthcare and all that through machine learning, and because of that so much of advancements are possible. Under finance, fraud detection, stock price predictions and all, yeah, even the experts sometimes fail to identify frauds. Even experts fail to identify when to purchase a share, when to sell a share and all that. But through machine learning, we can make it more accurate predictions and all that. Transportations like self-driving cars, traffic predictions and all that. So that's today's era is about the self-driving cars, and even about the traffic prediction. Google Maps already giving that. So if you say where to where you want to go, it tries to look at all the possible paths and looks at the traffic and all that, and then suggests the best path for you to travel from one end to other end. And that is possible only through machine learning, otherwise it was just impossible. So under the retail, you have product recommendation or a movie recommendation, a song recommendation, talk about any recommendation system used by Amazon, Netflix and all that is only possible because of the machine learning. We can't predict the human behavior and all that, but we can dump all the input available about the human's past behavior onto the machine and ask it to learn the behavior of a human, and then suggest what would be the next move of that human and all that, what product that person may want to buy today, or what movie a person wants to see today. So that's all depends on the mood, past, and all that. Just looking at that, we can recommend it. Natural language, yeah, chatbots, language translation, everything is possible only because of machine learning. So that's it for now. Thank you very much. Have any queries, please do write to me, given my mail ID. And all these videos and many more videos are available on my YouTube channel. So please do visit my YouTube channel for more videos, more information about other similar topics. So that's it for now. Thank you. Bye.